Hi, welcome guys. This is a new episode I've created for you guys who wants to learn C Sharp coming from Playmaker. Yeah, why why do I do this episode? Because for the last year I started using C Sharp intensely, and for me it's much quicker using C Sharp compared to Playmaker. And this is not by any means uh, to to telling that you shouldn't use Playmaker, because if you like it and if you think that you are uh, if you if you think that Playmakers it suits you, that you can use it further. But for me, I like Playmaker, but sometimes it's quite complicated to create a complex system, so I decided to started to use a C Sharp. And the last game I've created, uh, I wouldn't have any idea how to do that in Playmaker, because the complex system around it. So hopefully this episode or this series is going to be useful for you guys who just started learning C Sharp. And I will try to explain it as best as I can with the uh, by comparing the script with the Playmaker FSM. So maybe some of you guys that already quite familiar with the Playmaker can compare it and can get the idea, can understand it better how to code in C Sharp coming from Playmaker. So let's get started. Here I have a player movement. This is a very simple platformer, and as you can see here on the game view, we can move the character left to right just by using the get axis and using set velocity. And we can also jump here because we have a jump FSM. And as you can see, if I press jump, you can only jump once until you land again. You land it again and you can jump again. So we are going to try to do this system using a script, C# script. So okay, let's start. I'm going to duplicate the player first, and I'm going to rename the player to player C#, and drag this top, and let's disable the Playmaker player with the FSM. And here I'm going to remove the FSM, so make sure this player doesn't use any FSM, and we are going to create our script now. So I'm going to create a new folder called scripts, and then I'm going to create a new C# script. I'm going to rename this player movement, and let's double click the script. So we are opening the Visual Studio right now, and here, okay, I'm going to start to explain this. So basically, the with script with C#, your script name will be automatically reflected on the class name. So your file name, the C# file name here, should be the same. It shouldn't be different, because if it's different, you are going to get an error in the Unity. So make sure you note that. Okay, and basically here we have a to function. So whenever you see a keyword with a parenthesis at the end, this means it is a function. So and void is the return type. So you can create a function that returns nothing, which is void, or you can create another function that returns some things. And I'll explain this later as we learn further. But for now, function is to do something in the code. So you can put code inside the function, and then you can run the code from the function just by calling it by calling the function name. Okay, so if you see on the FSM here, I'm going to select this one, and as you can see, we have a state, and we also have variables. If I go to the movement, we can see that we have a float variable called speed, and the state, get axis, and set velocity. And all of this we can do this inside the script by declaring variable first. So to declare variable, you need to put a scope modifier. Usually you can type by typing public, or you can choose by typing private. Basically, what is public, what is private, variable that are marked public can be accessible from another script. So if you have a enemy script, probably it will be better to expose the health variable, so whenever the player attack the enemy, the player script can subtract the enemy health, like that. If you mark the health as a private, then it won't be possible for the player to subtract the enemy health. So for example, here I'm going to set the speed variable to a public, and the type is float. So basically we are creating the same variable like this in the variable. It's compiling right now, so that's why it's disabled. So if I go to the variables, here we have a variable called speed, and the type is float. So this is actually the same we are creating. And if I put the script on the player, for example, if I drag this to the player, we can see here the float variable. Okay, so now we are going to create a movement, and in order to move the character, we need to modify the rigid body properties, the rigid body component. So we need to create a variable that will hold our rigid body component. So I'm going to create a variable which is private, and I'm going to call this my rigid body, or my RB. It stands for my rigid body, and the name variable can be anything, just like the variable on your Playmaker. And basically what we are going to use this variable is to modify the movement, just like when we using the set velocity. And basically the set velocity is it's also store our rigid body inside this action, so we can access it and we can give it a velocity to the vector that we choose here. And this is exactly the same, but we need to declare it. And to use the rigid body, we need to grab our rigid body component, because by declaring the variable here, it's basically it's still an empty variable, and this variable doesn't know which rigid body we are accessing to. So in order to grab our rigid body, we can type my RB, the variable name, and then equal to get component, and we can put the type in this angled bracket, type the class or the component type, and then parentheses, because this is a method. So because get component is a method, we should always end a method with a sets of parentheses, just like start and update. And what is the difference between the start and update? Okay, start is basically our initialized or are being executed by Unity on the start of the frame. So whenever the game start, this get executed first, and it's only executed for one frame, so only one time. So whenever we need to initialize something, it's better to put everything inside the start. And update is basically called every frame. So whenever we use an action like get access and set velocity, and then we check every frame, this basically runs the code inside update. So this action and this action are executed every frame repeatedly, like whenever you put a code inside update. Okay, so now when we started, the empty rigid body variable will find the rigid body inside the game object. So get component can search for a component that reside on the same game object. So for this example here, the my RB variable will search the component like this. First, it will check the transform if it's a rigid body type, and it will see that okay, it wasn't. The next one also what it wasn't rigid body. It's not rigid body, and the third one and the fourth one is not rigid body. And once it found a rigid body, it will grab a reference. It hold a reference from to this component, so we can access it using the variable here. Okay, so we can create a float, or we can create a float here on the on outside the method, the function, or we can create inside the method. So for example, if I want to create something variable inside the method, I just type the data type, the variable type, and then the name. So I'm going to use name it h for horizontal axis, and then to use the get axis we can type the input dot get axis. And then since this is a method and it is asking for the axis name, we can type string in double quote and then type horizontal. So this is basically the same as here, get axis. Here we are getting the axis from the horizontal with a multiplier of 5. So if we want to multiply it by 5, then we can simply multiply it by 5 float like this here. Okay, so I'm going to save this, and then after that I can create a new vector 2, sorry, not vector 2, vector 3, since this is a 3D rigid body. And then I'm going to set the vector 3, the x-axis to h, so type h, and then just type this 0 and then the x0 first, sorry, the y0 and the z0. Okay, I need to name this name the vector, I forgot, name the movement, name the variable, save this, and then we can apply this vector to our velocity. So to access the rigid body velocity, just type myrb, the variable, the rigid body variable name, and then use a set velocity. Okay. Oh, not set velocity. Sorry, the I mixed up with this action name, so it's called velocity. So we are accessing the velocity properties here, and then we can insert the vector here. So it asks for a vector. As you can see here, the type is vector rigid body, and then just set movement as its velocity, and we can save this. Now we can try to move this character here. So put it on the ground, and then let's play this here, and as you can see, we can move this left and right. So we have successfully create this action via scripting. But now we have declared the speed float, and then we are using a fixed number here, so it's better to use this variable. So I'm going to type speed, and then I'm going to set this speed value to default to a 5 value. Save this. But of course, since it's a public, you can change the variable from the inspector here. So I'm going to just reset this value so it sets to 5, and save the scene, and let's try this again. Okay, there you go. And the process of using the variable, you can change this here to a smaller value, for example 2, and then you can see the result immediately. Now we need to create a jumping effect. So let's do the jumping, and for jumping we need to use a if statement. So if statement basically check whatever condition that happens inside the parentheses, and if it's true, it will execute the code inside here. So in order to use this, I'm going to use also input, but using get button down, and then I'm going to insert a string to the parent set of parentheses, and choose the axis jump, just like using the here. If I go back to the jumping FSM, as you can see here, get button down, and we are using the button name jump. So this line of code is basically just like this action, and whenever we press this, we are going to this state, and with this code, whenever we press this, it will going to execute the code inside here. And now I'm going to create a new variable, public float, a jump strength, and then let's set this to also 5. Save this, and I'm going to set our y velocity to this value here. So I'm going to change the movement dot y. So we already create this variable, so I'm going to use that, and then set to the jump strength, and then let's apply this back to our velocity, or we can just move this velocity here, cut, and put it below here. So why did I do that? So whenever we modify when we create the factor tree movement, we always input the h value from the input get axis horizontal, so the player can move left to right. But whenever we press jump button, we are going to change the y to jump strength, right? And then whenever we are setting the movement.y to jump strength, and then after that we are applying the movement to our velocities. So when we have a certain value on the y-axis, it will make the character starts to jump or move upwards, and then after that the gravity will kicks in. Okay, let's try this, see if it's working. Yeah, as you can see, there is a problem here, because whenever we start to jump, it will apply our jump strength to the movement, but on the next frame, our our y value on the vector tree movement resets back to 0. So this is a problem here, and I'm going to create a new variable called y speed, and then I'm going to get our y velocity. So type my rb.velocity.y. Yep. And then I'm going to change this 0 to the y speed variable that we have just created. Why do we need to do this? Because we don't want to change our y velocity for the player. So if the player is falling down, it means the velocity is it's around a negative number, of course, because the character is moving down. So whenever we set this to 0, it will reset that value, right? And the character will stop and then start to fall again, and stop and start to fall again. So it creates this illusion like it's stuck on the air. That's why we need to create a new float variable and get the y velocity, and make sure that y velocity never change unless we press jump button. Then we are going to set this movement y to a jump strength only for just one frame whenever this happens, and then we set the movement value to our velocity back. Save this. I'm going to go back to the Unity, and it's compiling right now, as you can see here, and let's try this again. Okay, there you go. As you can see here, the player can jump and then can land. But there is a problem, because whenever the player jumping, we can jump endlessly. And in order to fix this, we need to check for collision. And as you can see here, for the cube, I've already set a tag ground, because before in our Playmaker player, we are checking whenever we are jumping, then we are check for collision event with the collider tag of ground, and whenever this happens, it will send event landed, so we can go back to jumping again. And this means we are on air, and this is when we are landing. So we need to create exactly something like this. In C Sharp, we need to create a function that Unity already provide. It's called on collision enter. So sorry, type void first and then on collision enter, and then we feed the parameter using a collision type of collision, and you can name this any other variable, and then here. And what this is mean actually, whenever our player here collides with another object, this method will be executed, and the third object that we have collided with will be stored inside the collision info here. So we can extract the other object that we have collided, its tag, and then we can filter it by its tag. How to filter the tag? We can simply use the if statement like the jump here, but with a different comment, of course. So if the collision object, which is this parameter here, is a game object, and then we can check its tag. So using compare tag and sets of parentheses, we can insert the what is the tag. For this example, we are using ground, so I'm going to check if the object that we have collided with has a tag of ground, then do this code here. Okay, now I'm going to create a new boolean variable, and this boolean is going to be is on ground, and set this first to false. Save this, and whenever we enter the ground object, or we are colliding with the ground object, we are going to set the on ground to true. And I'm going to copy all of the method here and then paste this here and change the enter to exit. So whenever we are leaving the object that has tag of ground, then we are going to set the boolean to false. Now this value here we change whenever we jump, and you can see it from the inspector here. I'm going to okay, it's finished compiling. So now let's start to play, and then see, right now we are on ground, and whenever I jump it disabled the boolean, and whenever I land it again it's enabled again. So here we can use this info to add another condition on our jump here. So I'm going to use and double ampersand sign, and then on ground true. So we are going to check whenever the player hit the jump button and we are on ground, then we do jump. Otherwise, whenever one of this condition is false, this doesn't get executed. So it means when the status of our ground is false, this second condition is it will be false, so jumping will not get executed, so we cannot do infinite jump on the air. Okay, now let's see if it's working. There you go. I cannot jump anymore. As you can see, I can only jump once, and then after after the character landed, I can jump again. And here I'm going to check our jump value. How big is it? Okay, it's 10, so I'm going to change the jump strength to 10. See, we have a exact behavior. There you go. We have the exact behavior like our Playmaker counterpart. So if I disable the second, and then I'm sorry, and then I drag this down here, and let's start to play this one. There you go. We have a same behavior using C# script, and with C# script you need to only use one script to deal with this kind of movement. and it's quite simple. When you get around the ideas, the concept of the scripting, it's actually not that hard. So okay, hopefully with this tutorial you can see, don't be afraid to try using C Sharp, and there is a lot of another resource on the internet, on the Unity website, and if you once get familiar with the script, you will be able to create more complex system, and there is a lot of tools or pattern that you can use using C Sharp, and I'll try to create another episode covering those I'm sorry, those things, those methods. Okay, I hope you find this useful and you enjoy this tutorial. I'll see you on the next session. Thanks for watching and bye.